All right, thank you. Yeah, hi everybody again. I'm Parecki from Okta, and this talk is about OAuth 2.1. So I want to give some context for what this work is and share the status of it and kind of explain some of the motivations behind it. So as I'm sure many of you know, OAuth 2, the core, talks about a few different grant types and sort of sets up this framework for extending it. And one of the things that was left out of the core document was the concept of, or the actual description of access tokens. So at the end of all these grants is, an access token is issued, and then what the actual access token looks like is up to some extension to define. A very common and probably the most common, very likely the only actual implementation of access tokens ended up being bearer tokens. And this is the idea, of course, that if you have the token, then that is all you need in order to use it. So in other words, it is not sender constrained, as some of the work that we're now doing is trying to improve upon. So that turns OAuth into essentially these two RFCs. And you might notice they're sequentially numbered because they were published at the same time. So the bearer token RFC describes how these tokens are used and the fact that there is no structure to the token. So a few years later, mobile apps started becoming more and more common and more popular, and we needed to address the how to do OAuth in the mobile environments. So there was a new document created, which is Parecki, that describes a way to do the OAuth flow without a client secret so that it can actually be done securely in a mobile environment. And there was later a separate document published that talks about the specifics of OAuth in a mobile environment, one of which is requiring that those apps use Parecki, among other things. So then even later, JavaScript apps became more popular as well, single page apps. And one of the things that sort of evolved and became more popular after the original publication of OAuth is cross-origin resource sharing. And that really opened up the possibility for doing an authorization code flow in a browser. Before that, we kind of had to do workarounds, one of which is the implicit flow, which was essentially a workaround because browsers couldn't do a cross-origin post request to the token endpoint. So that ends up meaning that we're going to take this and now add in a new document, which I talked about earlier today, which is recommendations for OAuth in browser-based app environments. And what that really means is that the implicit flow isn't really necessary anymore, because it was always kind of just a band-aid for the fact that browsers couldn't do the authorization code flow. So the browser-based BCP is saying, don't issue access tokens in the front channel anymore, because there's no reason to. We don't need that workaround anymore. And that is also now advice that the security BCP is advising as well, which is just no app should be using the implicit flow. The mobile app BCP already took it out effectively a while ago. The security BCP also takes out the password grant because, as we know, one of the whole goals of OAuth was to avoid the need for applications to collect the user's passwords. And so that's now been taken out by the security BCP. One of the other things the security BCP does is requires Parecki for confidential clients as well, because it turns out it also protects against authorization code injection. So it's actually useful for a whole bunch of things that weren't even necessarily known at the time that Parecki was published. And lastly, security BCP takes out the use of bearer tokens in the query string. So we've got a lot of stuff in this pile already, and it's starting to look kind of overwhelming. And once you start looking at the extensions that are in the OAuth world, there's a lot there. And it's a bit of a mess and it's hard to navigate. So the goal of OAuth is essentially to take this picture of this is what we now recognize as, what is required to do OAuth, and actually simplify it down into what are we actually saying here? So if you look at what we've added and what we've removed, we've basically actually got this of, we're saying use the authorization code with Parecki, use the client credentials grant when there's no user involved in the flow, and two different ways to use access tokens. And that is really what OAuth 2.1 is. So it's meant to be a collection of all of the current state of all of the core RFCs. So if you start at the beginning, play all the RFCs in order, then what you get at the end of them after adding a few things and removing a few things is what's in OAuth 2.1. So this is meant to consolidate all of the best practices in the OAuth 2 specs, remove deprecated features, adding best practices, and capture this in a new name. One of the other goals this does is there's actually a lot of places in the OAuth core spec from 2012 that say you might be able to do this, but there's no implementations and no RFCs yet. So there's a lot of points that were sort of left for further exploration, and a lot of those now do exist. So for example, mutual TLS is a thing that does exist. It is an RFC, and there's a lot of those kinds of extensions that now exist that are well established that are able to be slotted into those places that were left open. So the one of the things that the OAuth 2.1 does is it then goes and adds actual references to those documents because they are now known to that they are a thing. What it does not do though is it does not actually bring those extensions into the core. So it is explicitly a goal of OAuth 2.1 to not actually introduce new functionality that isn't already in one of these other documents. So the scope of the documents are core, the two core documents, right? Bearer tokens and OAuth 2 core, the native apps BCP PXE, the browser-based apps, security BCP, and it's really meant to be those because those are considered the sort of baseline of what you need in order to actually do a secure OAuth flow. So we're still going to leave extension points for all the other future work, even when those may be considered something that is generally a good idea for all clients. If they're not yet well established, we don't want to bring it into 2.1 yet. So some of the specifics here are the grant types that are defined. If you read through the OAuth 2.1 draft, you'll find that it describes the authorization code flow with PXE, and it doesn't actually mention PXE by name. Instead, it actually just sort of rolls it into the authorization code flow. So someone new to the space reading through this document for the first time would end up effectively doing PXE, and they wouldn't necessarily know it by name. Of course, it mentions where that came from in the historical context, but it is considered part of the core authorization code flow. And the reasons for that are documented in the security BCP because it's absolutely required for mobile apps because there is no client secret. And then it also prevents authorization code injection, which is still a problem with confidential clients that do have a secret. And there's actually an unconference session on the proposal for tomorrow. If you are curious about seeing a demo of this, go vote that one up. That's from my coworker, Micah. But authorization code injection is a problem. Client secret does not solve authorization code injection. PXE does solve it. So let's just bring that into the core. And then the other grant type defined in the core is client credentials because that's a completely different use case, right? When there's no user present at the application. But yeah, it just leaves out implicit and leaves out password. One of the things that is confusing to people who are new to OAuth is when you start at the beginning and read OAuth 2 core, you see these 4 options laid out, and you start reading the motivations for those options as described in 2012, which no longer reflect how we actually consider to be best practices today. So we don't want people to have to go and read that document and then learn all that and then realize that half of what they just learned is now actually old advice once they finally realize the security BCP exists. So we're trying to sort of reset that baseline. A couple other things that requires are, and again, these are mostly from the security BCP being brought into OAuth 2.1, exact redirect URI matching, no more even allowance for wildcards, because that's been very demonstrated to be not secure. No bearer tokens and query strings. Again, just keep these out of access logs. There's the refresh token section, which talks about either sender constraining refresh tokens or making them one-time use. And then, of course, the implicit and password grants are just left out of the spec. One of the other things that we did, which is a recent change in the latest draft, is there's actually a new type of client that we've defined in the spec. And this is interesting because again, one of the goals was to explicitly not introduce new functionality in this spec. This is meant to capture the existing state, right? So you might be thinking, well, if you're adding a new client type, isn't that new functionality? But I want to describe what's actually going on here. So OAuth 2 defines two client types, public clients and confidential clients. And in its description, it says that public clients are not issued a client secret, or rather, I guess it says that public clients don't have the ability to maintain a secret. Confidential clients do have the ability to maintain a client secret. If you then read the spec, there's actually a lot of exceptions that are described in sort of carve-outs that are not these two client types. So what we've tried to do is capture that in a new name. Now, this new name is still like, first of all, this draft is not even adopted by the working group yet. So this is still all an individual draft. But this is written by myself and Dick and Torsten. So this is all up for debate still. But the name that we've come up with is called Credentialed. So the idea here is that it sits somewhere in between public and confidential. And the credential client is a client that has credentials, but whose identity hasn't actually been confirmed or can't be confirmed by the authorization server. So what I want to emphasize, though, that this isn't actually a new concept. This concept has existed in OAuth 2. So if you look at the text in OAuth 2, it'll say things like, if the client type is confidential or the client was issued client credentials, then the client must authenticate. And this kind of thing happens throughout the spec in a lot of places. So what this is saying is, well, what kind of clients have to authenticate at the token endpoint? Well, confidential clients, but also if the client has client credentials. But then earlier we said that public clients couldn't have client credentials, so there's a kind of a contradiction there. So by adding this new credentialed client type, it cleans up this text and actually describes what we're trying to talk about, which is confidential or credentialed clients must authenticate at the token endpoint. Right? Same thing with this one of, this was from somewhere else in the spec. If the client type is confidential or the client was issued client credentials or signed other authentication requirements, and that just turns into confidential or credentialed clients. So the idea here is that this distinction did exist already in the core spec. However, it was always sort of worked around with language to sort of describe it into particular instances, and hopefully this clears it up. And the definition of a credential client is that it has credentials, but whose identity is not confirmed. The concrete example of this would be a client that obtains a client secret but via dynamic client registration. So the problem or the issue there is, you can imagine a mobile app is a prime candidate for this, right? A mobile app can't be shipped with a client secret because it wouldn't be a secret anymore because you've just put the secret into the binary and distributed it via the app store. So no client secrets in mobile apps, right? But the first time a mobile app wakes up after it's downloaded, that instance of the mobile app could use dynamic client registration and be issued a client ID and a client secret unique to that instance. Now, that instance is then able to use the client secret to authenticate at the token endpoint, and that does improve the security of the flow overall. However, the identity of that app can't actually be guaranteed by the authorization server, because whatever that dynamic client registration call is can't have included authentication, because if it did, it would have that authentication would have been shipped in the binary, and then it wouldn't be, that authentication wouldn't be a secret either. So you can't just sort of push that problem down the stack, right? So in this case, the mobile app hasn't proven its identity, but it does have a secret which it can use to protect the mechanics of the rest of the flow. So that is an example of a credentialed client. And yeah, one of the pieces of feedback we got from this latest publication is we need this example in the draft because the other client types have specific examples listed. So that'll be added. But yeah, the idea there is that even though the identity of applications and whether they can authenticate are two separate issues, and they have been two separate issues since the beginning, and they were just sort of described ad hoc in the draft when that description was relevant. So that's the credential client. That's the sort of probably the biggest change from the core because it is a new term. But like I said, that term is still up for debate. Honestly, I never liked the term public and confidential anyway, but that's too late to change. We don't want to go that drastic. But this is, again, active ongoing effort. The draft you can read at the spec at that tools link. I also have a summary of it at OAuth.net. And the status of this work is it is still an individual draft. We have a call for adoption out on the mailing list right now. So so far it has received, I believe, entirely positive support. So go ahead and chip in on the list if you would like, and express your +1 to that. And with any luck, we'll adopt it in a working group and continue the work from there. I believe that is everything I wanted to cover. So thank you, and I'm happy to take questions on this as well.
Thanks, Aaron. We have a lot of time for questions.
The question, is there an expiration associated with credentials issued to the mobile app? So again, there's no new actual functionality being described by this spec. So the dynamic client registration, I don't think actually has any specific requirement for expiration of those credentials either. But all that 2.1 is doing is saying that there is this term credential client, and then we can use that term elsewhere in the document when that concept was already referenced by other language. So however you come to the use of credential client isn't actually relevant to 2.1. So dynamic client registration is one example of how you would end up creating a credentialed client. It's up to you whether you would want to have those credentials expire, but that's a dynamic client registration issue, which is an extension to OAuth. Another question, if the dynamic client registration is protected with the access token that was issued beforehand, isn't that enough to identify the app? No. So the problem is, so the dynamic client registration can, of course, be protected by an access token. But in that case, you would have to get that access token somehow. How you get that access token is out of scope of dynamic client registration. If you can give the app that access token in a way where that app's identity is proven, then the dynamic client registration credentials issued from that are identity proven credentials for the app. And then it's not a credential client anymore, it's a confidential client. But there's no way to do that in a mobile app environment. There's, in a mobile app environment, at least shipped via the app stores, you ship a binary to the app store. That binary is downloaded thousands of times. It's the same code. Once it's running in the app, it makes an API call. That API call looks like any other API call that anybody could make or mimic. So there's no way to ship anything in the app that can actually ensure that the thing making that API call to register the client is actually that app. So that dynamic client registration call has to be unauthenticated because there's no way to ship authentication into that call. And once it's unauthenticated, you then can't prove that the app is really that app. Now, if the app stores provided, or I guess the app stores plus also the app runtime environment, like iOS and Android, provided a way to make API calls that would be signed by the app store's distribution system somehow, that's a whole different story. But as far as I know, that does not exist. So like Apple has the opportunity to help out here a lot, and they could really help out this whole idea of proving apps' identities by providing a mechanism to use the signature that already exists in the app of the signed file to actually go and make API requests that use that signature. But anyway, that's a whole different can of worms, and I would love to explore that more. But that's, again, a dynamic client registration problem, which is not being brought into the core. It's just still an extension. But the concept that Spring brought into 2.1 is this idea of a credentialed client that has these properties. Okay, let me keep going in the questions.
Aaron,
if there's no expiration, yeah.
Would you mind if I chime in, just add a thought?
Oh,
okay. This
sure.
is Thorsten speaking. So regarding the protection of the access token, if you really want to make sure that you're able to identify the client, even the mobile environment, then you must use a confidential client, and that means you must move the OAuth client part into the backend of your application. This is always an option you should keep in mind. In a mobile application in the front end, you will never be able to ensure this is really the application you want to talk to. If you wanted to do that, do it in the backend. All open banking solutions that need to make sure that they are really going to talk to the real application representing a certain legal entity, move the OAuth client logic to the backend. Just my 2 cents.
Yeah, absolutely. And I think, but I think even more than that, just moving the OAuth client to the backend still doesn't prove the identity of the app. So it proves the identity of the OAuth client, but if you have an app accessing that client, you've still got that missing link between the two.
That's
so
correct.
You have to solve that some other way.
Exactly. And it also means that you have to narrow down the interface between your backend and your front end. So any kind of front end could use your backend.
Yep, exactly. Okay, let me keep going to the questions. If there's no expiration of the registration, is there deregistration, for example, when an app is deleted? Again, that's a dynamic client registration question, so not really relevant to the scope of this document. Another question, how does this impact OpenID Connect? Does that need updating to reflect OAuth 2.1? Also, any similar cleanup of specs coming to OpenID Connect 1.1? So the short answer is nothing about OAuth 2.1 should be a surprise, because all of this is already being described in current OAuth 2 work. So OAuth 2.0 plus all of the extensions plus the security BCP, that's what's being captured. So if there are things in OpenID Connect that conflict with the security best current practice, then those should already be fixed. They should be being fixed in OpenID Connect because they, aren't then following best OAuth practices, which OpenID Connect is based upon. The goal is that there's nothing specifically in 2.1 that isn't also in the security BCP. It's just meant to be a roll-up, right? So, and I guess this is, I'll grab this next question as well because it's related to this, which is, how does deprecation of the implicit flow influence the OpenID Connect hybrid flow, which is basically a combination of the implicit flow and authorization code flow? So there's, again, two things going on here. So the OAuth 2.1 is not going to describe the implicit flow. It is just it's not going to include response type token because that is not secure and nobody disagrees with that. Even from the beginning of OAuth 2, it was always known that it was not as secure. So that's why there are these exceptions in it, which say like, don't issue refresh tokens to these apps. There was never even a mechanism created to issue refresh tokens via the implicit flow because of its lack of security. So OAuth 2 is not defining response type token. Now, OpenID Connect also does not define response type token. OpenID Connect defines response type token plus ID token or token plus code, right? All these hybrid response modes. The reason that it's doing that is because OpenID Connect has gone and added mechanisms to prevent access token injection, right? With response type token, there's no access token injection and there's no access token leakage prevention at all. Parecki solves access token injection. What also solves access token injection is using the nonce parameter and using the AT hash parameter in the ID token to verify the access token. So if you've obtained the access token via the redirect in the front channel, you need to verify that it isn't injected. So you can use the ID tokens nonce to verify the ID token and signature, verify the signature of that, and then use the AT hash to verify the access token. That's fine. That prevents access token injection. It does not prevent access token leakage because there's still the chance that it leaks out of the redirect step. That's a different problem. So, the security best current practice says prevent access token injection, and you can do that using Parecki or using the AT hash property of an ID token. That is an OpenID Connect thing. That's not an OAuth thing. So the OAuth core and OAuth 2.1, which is still supposed to be just OAuth 2.1, is not defining response type token. But it's also not saying you can't extend the framework still, right? So you can still extend OAuth 2.1 to add in new response types, which OpenID Connect is doing by adding in response type token, ID token, or whatever, as long as it still prevents all these issues like access token injection and token leakage. So hopefully that answers the question. Like anybody is still free to extend OAuth 2.1 just like they happen to extend OAuth 2.0. Just make sure that you are extending it securely and not introducing new problems, but that's up to the extension to define and ensure that it's being protected. I guess the last thing I will say about the AT hash issue is that the reason that the thing I don't like about that solution is it puts the entire burden of protecting against access token injection on the client rather than enforcing it at the authorization server. So if you want to trust your app developers to properly protect the OAuth flow or the OpenID Connect flow using the AT hash and making sure that they're doing the signature verification of the ID token using the nonce and checking the AT hash to validate the access token, that burden is on the app developer to actually do properly. If the app developers do it properly, it's fine, that attack is prevented. If the authorization server enforces Parecki, that prevention is enforced at the authorization server level before an access token is even issued. So it's easier to sort of ensure that your entire ecosystem is secure by just using the Parecki mechanism with the auth code flow, which you can also use to get an ID token as well. So yes, thanks. I think that's the last of the questions there. And we're just coming up on time.